So we're back on the AI Journal LinkedIn Live. It's been a few weeks since I've been away, and I haven't done one of these for a few weeks. And even today, we're starting later than expected. A few technical issues from my side, which I really apologize for. But it is very exciting to be back. We've got a lot happening with the AI Journal, and a conversation me and Tommaso recently had. I really wanted to bring you on the show, Tommaso, to talk around a real exciting area, which is AI, but also how it's used within the investment world, within the financial world, and a topic that's very interesting to me because it can sometimes look at when you're using these different technologies of how they can help. But before I dive into lots of questions I've got for you, Tommaso, I'd love to just get a bit of a understanding of, or share with our audience who you are, what your background is, and what led you to be the CEO and founder of MDOTM today.
Yeah, so pleasure to be here. I founded MDOTM 6.5 years ago in London, and we're now a team of 50 people. And basically, we do two activities. On one side, we manage money with a sub-advisory business model for institutional investor only. And on the other side, we've developed a technology that basically supports investment decision-making processes. We have roughly 1 billion euro that we sub-advise, meaning through investment product that could be funds, discretionary mandates, or certificates. And on the other side, our technology used to support roughly 30 billion euros as of today through different tools, and in particular a platform that we've developed over the years.
Yeah, very cool. And how did you come across it then? What was your kind of journey, Tommaso, with thinking? You said 6 years ago. Was it quite an organic journey to thinking this is something I need to start, or was it something where you really saw a gap in the market, or what was it that gave you that kind of eureka moment, that moment to think this is something businesses need and something you're going to go away and build?
Look, I come from econometric as a background, and coming from finance and econometric, I've always realized that because the financial market are becoming so much more complex every day, you feel like you're always working with the tip of the iceberg of the overall information we actually harvest. And so I was looking to find a way to come up with a more scientific decision-making process, I would say, to a more informative decision-making. And therefore, I call a long-time friend of mine, Federico Mazzarin, who's a physicist and a professor at university. And we combined our two backgrounds, myself, finance and econometrics, and his background of data science and machine learning. And the goal was not really to completely destroy what has happened over the last 100 years of financial modeling, but rather was to allow these models to become more adaptive and more able to really work well in an environment which is the financial market, which is ever so changing. So that was the background. The journey has been, as every young company, it's been intense and I would say pretty fun. So we started really out of a garage, myself and Federico, in London, and then we worked for 3 years, basically almost in a stealth mode. Then we were lucky enough to be picked up by Google for entrepreneurs, who selected us, brought us to the Silicon Valley, gave us resources and mentoring to support our growth. And then we came back to Europe. We raised $2.5 million 2 years ago, and then we finalized another funding round basically 5 months ago of another $7.5 million. So together we raised almost $10 million in equities. And basically that allows us to be today a company of 50 people. We have a deep focus on the R&D and the technological side. We employ roughly 40 people in our tech department, which is composed of 3 elements: research and development, which comes up with the new algorithms, comes up with the ideas, mission control teams that's there to make sure that everything runs smoothly every day, because you need to have always full control of that. And then finally, the engineer, which for us are software engineer, and create all the architecture and the technology to allow our artificial intelligence to wake up, run every day, basically.
Yeah, very cool. So I'm basically seeing a very similar story going from garage to what is now a team of 50 people in a very short amount of time. It's very impressive, and it's very cool to see what you've built. And I remember having conversations with your team around what's happening and what you're seeing, which is what I'd really like to delve in from your experience, Tommaso, because it seems that this area can sometimes not necessarily be misunderstood, but can be looked over. And especially when we speak to people from a data science field or data developer, they don't always get to see the trends or the ins and outs of investing and how AI and how machine learning and how these new technologies we seemingly have at our fingertips that you and the team are the companies you're working with. So I'd love to know, what is the state of AI investing? What does that look like? And what's its position today with AI and investing? How do they come together, Tommaso?
Yeah, I mean, I have to say that there's a lot of demystifying that needs to be done here, because people perceive artificial intelligence as being something that it's like a crazy computer able to do everything. That's not really the case. It's much more like a powerful hammer that can do different things, but still is a tool. So it's important to understand first, what is artificial intelligence. We could argue that an equation is when y it's equal to something that it's very, very well easily defined. It becomes, and that could be an econometric model, a quant model. It becomes machine learning when some of these dynamics of this equation are self-determined. To this extent, a gauge could be considered as machine learning. I don't know if that's really the case. And when you combine different machine learning techniques, that's generally defined as or considered as artificial intelligence. That's just the definition, but at least we got that sorted. In general, the state of artificial intelligence in investing is it's taking a new leap, because at the beginning, artificial intelligence in the world of investing, which is in the financial industry, which is a very complicated industry, has covered a lot of the more operational topics, the easier to be solved, I would say, where there's not much decision-making process and ever-changing complexity, but there is a very complicated job to be done. So that was the easiest topic to be covered. Where is the interesting bit, and that's where we are is in the assisted decision-making. In general, this is not just in finance, but humanity has reached a point that we consider the end of the data-driven decision-making era. Data-driven decision-making era, to us, it means a lot of data, a lot of statistics, and then it's just down to the human to make the decision. And we're moving into a new era that we consider the era of assisted decision-making, where computers not only they produce these statistics, but are also able to read through them and provide a decision. Okay, then you can accept, reject, or consider within your activities. Now that's the most interesting bit, and that's also the most difficult bit, because decision making, it's challenging also to understand how a human makes a decision, right? So it took us a lot of years to understand how a human makes a decision and how a system can make a decision. And really, this is what is the state of the art. In general, we have to consider that these techniques are not anything completely new. These are all like things that have been theorized, studied, and developed over the last 50 years of computer and finance modeling. But we are at an interesting point where all these different fields are combining together, and we're starting to see really a lot of added value. So this is basically where we stand.
Yeah, very cool, very cool. And it's great to hear what you're saying about demystifying it as well, because it's such an important point that people really understand how these things can help people and how it can have the end result to the end user, which I always find massively beneficial, and to really how you can leverage these technologies to do amazing things, which you and the team are doing. And you obviously deal a lot with AI then, and you and your team are learning very quickly. And as you said, you built up to a team of 50 people. With that, I imagine comes a lot of lessons. And I'd love to know what your kind of lessons are, Tommaso, or what you would recommend to ensure AI success. So how can companies ensure AI success? And is there anything that you can share that you've seen that really, or what are things people need to think about to ensure AI success?
Yeah, one of the things that we need to demystify again is the concept that people perceive AI as two guys on a laptop stuff. That's not really the case. Two guys on a laptop can, maybe start something very, very small, but to develop something that actually adds value, you need to have total 100% focus in what you do. Build a company, or at least a very large team of people really dedicated towards this, developing this new field, because there are multiple different activities that one needs to do to ensure that there is something of value afterwards. I would stress that these are basically 4 activities. The first one is have a proper, rich and robust base research activity going on. In general, research and development has 2 main fields, we could say. One is base research. Now, base research is when you wander the field of unknown and you see if there's something interesting. And then there is applied research. The base research is the first thing where everything has to start. You need to have partnership with universities. You need to have partnership with research center to make sure that you have, and also with professor, even though some of the publication might not be very, very relevant, but it's important that you have the chance to explore the unknown. That's a little bit. A tiny, tiny bit of that might be of some sort of relevant. When it's relevant, then you need to have a very strong internal team of R&D. That's applied research. That's where you need to really have the ability to work within teams and have different teams that can compete one to another, that can have that positive energy of trying to do things better than the rest of them, to make sure that you actually produce something of value. Then, and this is basically covers the 2 very important aspects, but are very linked to R&D. One is base research. For example, we have founded a lab that's called MDOTM Lab with 5 universities. We have currently 48 students, PhD and professor, carrying out this base research. And that's one activity. Then we have the applied research, which is led by my co-founder internally. Then, and that's one thing. Then you need to have all the technological software and architecture to make sure that everything runs smoothly. Imagine how many data points you need to evaluate from different sources, that you need to make sure that they're clean, that they work properly, and they actually provide value. And also you need to have the technological element to make sure that both the R&D can work and the client can get the final output in the most seamless way. So that's a very important thing. And that's really down to software engineer, IT guy, one could say. There's a lot of cloud computing going on. So you also need to have DevOps and system engineer able to make sure that can scale as well. And that's a different topic altogether. It's no longer related to artificial intelligence, but it's all the muscles to make sure that your intelligence can actually work every day. And then finally, the 4th element is what we call internally mission control, which does mission control and risk management. But it's very important that you have people, a team of people dedicated to make sure that every day they're checking on what's the model, on how the model are working. Of course, this model, even though we're not in the trading space, we don't trade, it's not our algorithm are not a trading algorithm, they're investment algorithm. They take position, of course, they rebalance when market conditions do change, but it's something for institutional investors. It's not for, which move a lot of money. It's not for, a small amount of money that gets traded every day. Nonetheless, our model every day, they wake up, they run, and we make sure that happens very, very smoothly. You need to have people dedicated to that. We call this team mission control because it reminds us the room at NASA, which is called mission control, which makes sure that the rocket launches and lands itself, but still there's a lot of engineer that make sure that everything runs smoothly. We don't have engineers here because we have them in the R&D. Here we have financial analysts that look at the output of the models and actually look at them, make sure that they are correct, that they're meaningful. They don't have discretion on how the model is working and the decision that they're making, but they have all the discretion possible to make sure that the process is similar. These 4 pillars are actually key to make sure that what you develop has some sort of value, not just in the past, but going forward, because investing is not a matter of developing stuff. It's a matter of once you've developed those stuff, that actually provides value as a market evolve in the future.
Yeah, very important. Very good points that you made, Tommaso, about how companies can follow some real good ways to ensure AI success. And I really like the fact that you've come up with that idea, or you use that model of having, what did you say, a mission control. So it's really cool to see. And I might take that to my own business, because it really is so important to really have the right operations behind it and to have the right kind of testing or the right kind of people that understand what you're doing. So I think that's such a great point for the audience to take away, and more of a business strategy decision, if anything else, alongside how to ensure AI success. But I'm keen to know.
And if I may to add other thing, which I think is interesting, is you need to have different people with different characteristic and different ambitions and goal in life to do different jobs. Somebody who's there in mission control maybe is not the best one at developing the algorithm, but believe me, the one who are able to develop the algorithm, they could not be bothered into making sure that that works every day. They think that that's not important, but that's really key. So also finding the right people in terms of character, skills, ambitious, and combine them together is really important. So each one can do their job very, very well. It's one of the things we learned at the very beginning of our journey.
Yeah, and that's great to see it set with you for the past 6 years as well, or however long it was in that you came up with it. And it's I always think, Tommaso, like the power of knowing your own strengths. So it's very good to know you're empowering your team to say, what role should you be in, what area of mission control should you be in, or what role of the business, should you be in to lead that. Because I think, and I don't know if you agree, I think people can sometimes, or businesses can find themselves in a situation, especially when you're dealing with high technologies, where they're not necessarily the right person. They might just have the right strengths, but they have great strengths, but they're just in the wrong role. Like you said, you're trying to put a developer in an operations role. They want to be a developer. Do you see the same thing with what you're dealing with AI?
Absolutely. I mean, I come from a professional background. I used to play professional ice hockey, so I do believe in teams more than anything, probably. And you cannot have all strikers or all defenders or all goalkeepers. You need to have a team. A team is made of different elements with different skills and different characteristics. And actually, I believe that when you have the right team and you combine them together, and each one has the chance to strive in the role, in their position, you achieve massive success. And so it's quite funny, but if you think about it, we're talking about artificial intelligence and we're talking about people, because at the end of the day, it's down to people, the people who develop this technology, the people who monitor them. So you really need to put together a proper structure to make sure that this complex thing can really be developed. It's really not a one-man show or a one-man band. It requires a team effort, because it's such a complex matter. So regardless of the application, but that's how we view it in any way.
Yeah. And have you seen any kind of shifts to that as you've grown, Tommaso? So you're saying you've gone to like a 50 person team, which is really impressive. Have there been things where you've seen that firsthand of trying to, especially with the industry you're involved in and supporting, have you seen where you have to move people to their strengths to make sure that the business can give a great outcome?
Yeah, absolutely. I mean, and I mean, the count is still going, because we should be about 80 in the next 6 months. So we're growing quite a lot. Nice. I have to say that, as we grow, I consider artificial intelligence a little bit like creating a very, very good restaurant. Okay, you might start with thinking that the recipe and the dishes are the most important thing. You realize that's one thing, okay, and I consider the recipe and the cuisine probably the artificial intelligence bit, but also the operations and the the table, the room, how the food gets served. It's massively important. So as the company grew, we shifted focus more towards R&D and mission control, which has always been our focus, into also the team of engineering. The team of engineering, which now has its own CTO, Chief Technology Officer, that comes from a very, very large company. And but basically, they create all the software architecture to make sure that everything runs smoothly. And the more the company grows, the more we realize how important it is to have a very scalable software architecture that allows two things. On one side, your system report monitor to run super quick, super fast every day, autonomously. That's obvious. But at the same time, it allows you to multiply exponentially your effort in R&D. So this is like, we consider ourselves similar to a pharmaceutical company. We have a portfolio of research projects that we carry out, and we realize that the more we research, the more these processes are somewhat and how connected. And we realize that something much bigger could be done if we combine them together. So if you don't have the software architecture to support your R&D efforts, you're missing out a big piece of the pie.
That's such an important point, Tommaso, because that's where some certain people can really. It's like when we look at things like if you're trying to implement new software and you don't look at the proper roadmap of where you need the right team in place, or actually missing that point. So that's such a vital point, Tommaso, especially as what you're involved in and what your customers or your network, I'd rather say, is finance and financial markets. Can be very, and I think this is fair to say, unexpected turns can happen, and the unexpected can happen. You see it with global events, and you see it with local events. And I think it's so important to have that kind of, I think it's fair to say, adaptable structure where you can almost, pivot to deal with these unexpected moments. And I think I'd like to ask then, with all these different unexpected situations that can happen, can you tell the audience how AI can adapt to these situations and how it can make the best of what sometimes seem very dangerous situation or very unexpected moments? How can you make the best of them?
So this is a very relevant topic, considering also what's going on in the financial market over these last weeks and months, and what we can expect in the future, because we're still into this tough moment, we could say. But we have to consider that to understand how artificial intelligence can adapt, we have to understand how a human being, us as a human being, we make decisions. Okay, we keep referring to models and algorithm as something that looks back into the past, right? That's something that almost looks at the future through the review mirror of a car and tries to drive forward. But that's not really, that's probably what old algorithms would have done, but that's not really how we see that happening. Think about us human. We make decisions using two elements. First element is experience. Experience is solely based on the past. Okay, so we look at dynamics that has happened throughout our career, our life, the thing we've studied. That's all things in the past. Okay, that we combine in a non-linear way. So we combine things that maybe are very far away, things that are more recent, in a non-linear way. So there's no time sequence of this event. We combine them, and then we measure. The second element is measuring the status quo, data evaluation. We try to get the best picture to assess the status quo, and then we use our experience to make a forecast for the future. Okay, regardless if the forecast that we make is right or wrong, how us as human we make decision is experience and data evaluation. We do this every day. How do you decide to go attend an event? You decide to attend an event because you tend to know that events are good moments to catch up with new trends, listen to new companies speaking, or companies that have a deep focus. Maybe you know that the food is good and it's a good way to network with some colleagues. Okay, that has nothing to do with the event that you're thinking about going. That has to do with things like events you've been in the past, that your friends have been, your colleagues have been to. That is experience. Then it's a matter of who's speaking at this event. Is it my sector? Maybe it's not in my sector, so it's not relevant. So in life, we combine always this. How do we make investment decision as human? We use experience. We think about past market dynamics, past black swan events, past regimes that happened in different moments in our experience. It's all based on the past. We combine this and then we measure today and we forecast the future. So how artificial intelligence in our case works is very, very similar. The difference is that the experience bit, that for us it's done through a technology that we call the non-chronological learning, works with the depth of data. So rather than remembering a few events like we do as human, we cannot remember 20,000 events. We remember 10 events, 15 events, 20 events maybe, okay? The machine can remember, hundreds of thousands of events, and we combine them in a non-linear way. And at the same time, we measure the status quo. How's data looking today? What type of regime we're in today? And combining the two elements allows us to create a forecast of the future. Now, how does it adapt? It adapts because of two things. First thing is how you measure today. Think about this. Our experience after and before the invasion of Ukraine from Russia has not changed. The experience has always been the same, right? The day after the invasion, that was it. It was before and same experience afterwards. What changed was the status quo. Before we were like, maybe it's not happening. It then happened. It changes the status quo. and then we reacted as human. We come up with a new idea on what could happen in the future.
Yeah.
So first thing is how you measure the status quo. So it's very important that you have a system. For us, it's we call regime analysis. We analyze what type of regime we're in, what type of market condition we're in, and that's one step. And the other thing is throughout time, as market change, and believe me, market do change and evolve. And it's not just the element that people think about, the big drawdowns. It's not just that. It's dynamics that you don't even see, but they're happening, and the market does evolve. It becomes a little bit different. That get picked up by the algorithms that have the chance to keep learning. So it's called continuous learning. So they keep learning from new data. Of course, the two processes are different because one is very quick to evaluate the status quo. The other one takes a little bit of time because as we do as human, the different bit is always that the advantage of technology is technology can forget much faster than we can do as human. We tend to remember always the negative stuff, and the positive stuff is not usually it's more obvious maybe, but it doesn't stick in our brain so much, whereas technology can learn and forget. So combining this element can create something that this is also why it's so valuable to our clients, for example, or to the market itself, if done properly, because it provides something with a different point of view, completely different, with a different mentality, with a different point of view, with different biases. I wouldn't say that there are no biases. Everyone has biases. These are maybe less biases, but definitely there are no emotional bias. So it can combine very well, either if it's a full strategy or if it's just a tool to support investment, human decision-making processes.
Yeah, that's a great roundout. That's a great summary, because it's I like your point as well. We what was it, the comment I heard that you can have 1,000 good comments and one bad comment. Which one would you remember? You'd remember the bad comment. And it's just always the situation. It's looking at when or like 1,000 good reviews, one bad review. As a business, you'd focus on the one bad review, and really you're probably doing pretty damn good if you've got 1,000 great reviews. But it's really interesting to hear that as well, because it's how quickly it can change. To me, it's very exciting as well to feel how I've never considered it before. Once something happens, all those decisions, almost like a decision tree, everything changes, because now it's like, okay, what could happen from that decision, and what could happen from that decision, and what could happen from that decision. And for the financial markets, it's so important because they're involved in everything. Everything has, in my opinion, revolved. That's why I think fintechs are such a either dangerous or such a very well primed company for the modern world, because they are doing a lot across various different data points and using it for financial model. But I always think how that can help. And I'd like to know then. So you're saying how you've discussed how AI can adapt, especially in financial markets, Tommaso. But what would you say to people that are potentially just starting their journey, just taking their first step? They don't necessarily, or say they've got their first implementation of a first team, and they've got a first maybe POC, or they've got a first kind of idea. What would your recommendations be for them to start their journey in AI, specifically for their business?
So I would say that there are two answers I would give. One very quickly, which is for the one who are trying to do it themselves, in terms of the people developing artificial intelligence, whether it's a team, a small company, just an individual, always ask yourself why it should work. What's something that it's I've always I become a little bit angry when that happens, is when some researchers or developers, they don't ask themselves why it should work. So why do you think that the system you've developed is able to capture something? What are the dynamics behind that? Don't stop at, we try this algorithm and some statistics are good. That's just not relevant. It might be useful if you're doing something very, very, very basic, but given that this is definitely not basic, you need to ask yourself always why. So that's what I would tell them if they're doing themselves. If you're a business, more structured business, the world has changed. Okay, or if you're either in finance or somewhere else, but in particular in as an institutional investor, the world has changed. It's no longer you no longer need to hire 20, 30, 50 people to do everything yourself. You can have much more senior people, so junior along the way, and collaborates with a lot of providers or companies that have their own economy of scale in develop certain technological solution. We think that with this artificial intelligence, we need to have something going. Okay, that something going, usually it's 100% more successful if it's you coordinating with companies that have that deep know-how, that deep understanding of the topic, and you can use them and be more like a builder rather than buying and building rather than developing and creating everything yourself. I always stress one thing: to do something great, you need to have deep focus. Okay, if your business is not developing a certain technology to do certain stuff, then probably you are much better off into doing your own business and then buying from those companies that have those economy of scale and that focus. And think about how focus helps a company. It helps by hiring the right people, putting them in the right processes, with the right incentives, with the right culture and technology. And that allows ultimately to build something much better than what you can build internally. So that's basically my suggestion. Again, for the one doing it, which is usually very small, doing something themselves, always ask yourself why should it work? And then for the companies more established that want to really implement within the process, think about buying and building, different bits, have a strong due diligence, hard due diligence on the different providers, and understand how each one can complement your business. Because it's not going to be one for everything. It's going to be probably a multitude. So you definitely need to have some people internally able to evaluate these partnerships.
Yeah, so important as well, isn't it? To anyone that is within, to anyone watching and anyone watching the recording as well, how important processing is and how important getting those processes are right, because we've seen it where companies can fall on their feet because they just haven't set off with the right agenda and they haven't had the processes in from the start. And I always think the smaller things are the best form of mastery. So if you can't get them right at the early stage, you're not going to get them right at the bigger stage. And I think it's really important that you've made a note of that, Tommaso. And I'd also encourage, just before I've got one more question, we've got a couple of questions from the audience as well. So if there are any more questions, please send them in for Tommaso. And if not, I'm sure a member of the team will answer them afterwards. But I also recommend to the audience, I've noticed, and I spoke to your team member, Alessia, who was fantastic at explaining what it is you're doing from the marketing side and the angle of really helping your area understand all these topics. And you've got quite a lot of research as well on your website, which I think's headed up by so I would definitely recommend people go and go and watch that and go and look at the insights that you publish from MDOTM, because it's really cool. It's something that when I was looking at it, I was like, I had no idea these are the kind of thinking and strategies that go into this world of financial models. So very cool to see it. So I guess I've got one or two questions I want to ask, but we do have a question from the audience about what I was going to ask. So I think the question I was going to ask, and maybe you can just do this as a prelude to the question from the audience, Tommaso, is Alice. Give us a bit of a background. I think you were mentioning it earlier. What is Alice, and what's its role, and how does the team, how does your team interact with it?
Yeah, so ALICE is our technology that stands for Adaptive Learning in Complex Environment. I mean, we work in financial markets. I think there's not a more complex environment than that one. So that's how we come up with the name. So how ALICE works, it creates, so it tries to mimic to a certain extent that experience and that evaluation process, as I was mentioning before. So how a human would come up with that decision. In general, the things that our technologies tries to do, it's always two things. On one side, come up with the best decision possible on the financial market, okay? And on the other side, make sure that if she's wrong, we're not overexposed on that one. And is very similar to how a human and how anyone would make a very sane decision. You would consider the risk of being wrong. So by combining the two elements, we can actually come up with something that is both very aggressive, so we can have certain, straight and very strong ideas on how to position, but at the same time, edge our bets by positioning on something else that might be very decorrelated and have different dynamics. In general, ALICE, because it's an investment decision making, has to rely on the 3+1 element that determine every portfolio. So every portfolio in the world is composed of expected return, expected volatility, expected correlation, okay, variance and covariance, plus tail risk, okay. So we have different techniques to cover this, but in general, Alice makes a probabilistic forecasting of these three elements, and at the same time evaluates the precision of each one of these. So from time to time, we could be more aggressive on expected return or more aggressive on correlation. So for example, now that we are living a very complicated moment in the market, it's very interesting because the return, the expected return part of our algorithm of Alice is not so, it's more like on a longer term. It's more like strategic expected return almost. Whereas where we are very tactical, so where we move very, very quickly, is to really capitalize on the correlation element and the volatility and the variance element, which now in the financial market are actually very, very informative. So by combining these, we can actually create something of value. I have to say that even though it's been, this year, 2 years ago, it's been tough. 2018 has been tough. The last 4 or 5 years not been very easy on the financial market to a certain extent. We've been very lucky because we started the business at the end of 2015. Okay. Yeah. So by then we went through with our algorithm, with live money of institutional investor, we went through Brexit, the election of Donald Trump, that yes, the market were positive, but the dynamics, as I was telling you, the dynamics underneath were changing. So different market condition. Then we went through 2018. There was a cold crash at the end of the year, and then the rebounds of 2019, and then COVID, and then now a war. So I have to say that, and we did this. I mean, COVID, we had already 500 million that was running on our algorithm, so it was not just two pennies. So I have to say that I don't know if we're unlucky or if we're very lucky, because we had the chance to really see how the process was working in different moments, and there was a lot of learning as well to be taken, and also a lot of proof that the methodology, the approach, if done with a very scientific approach, actually brings a lot of value. So I would say that these are the elements to take into consideration.
Yeah. That's really important, Tommaso, as well. And it's something I definitely resonate with. I always say, like, if I could turn back time and stop the pandemic from happening, of course I would. But I also think because it's happened and because of what's happening at the moment, it provides us valuable lessons as people, how to make better decisions and how to do better and how to do things. So I love that you're applying that kind of mindset to your business and to, what's going to be next. And especially, as you said, the situations you're in that are constantly changing. So I have one question I'd love to ask Tommaso, and then I will get to a question from the audience, but it's just really on my mind because I want to learn from this as well. Can you share what the main challenge was when designing and developing Alice? So I see people try and create their own technology, and they do go ahead and create their own technology, and they create their own algorithms and whatever it might be. But there's a lot out there that are thinking, what if? And if I could, is there anything you can share that, or maybe what are the biggest learning lessons from designing and developing what seems to be a real robust and very well-orientated solution you've got yourselves?
Yeah. So once again, there's been a lot of learning, and I have to say that we had first of all, going back to how of course everybody would stop COVID before it happened. But there's also a sentence from Roosevelt, that quote from Roosevelt that says, "A smooth sea never made a skilled sailor." So that's really the element. And I have to say that over these years, not only we had experienced a tough market, but also tough market with the new technology and a growing team. So I have to say that the heads up that I would give into really developing this technology is start with a very clear vision. You need to know, even though there's a lot of research going on, and so therefore the outcome might vary from what you were expecting at the beginning. You need to know where you're going. You really need to know what's your hypothesis, what you're trying to achieve with this technology, with this development of artificial intelligence. What is the thing that you're trying to achieve? That's the first and most important thing. Have a very clear idea. Second thing, put the right structure in place. I told you before, base research needs to be separate from the applied research, and mission controls needs to be applied separate from research in general. An engineer needs to have his own agenda, his own goals to achieve, to make sure that everything runs smoothly. So have the right structure is critical to make sure that you can actually do something of value. And then finally, develop a culture of hiring the right people to do the right job. One of the things that people try to do with this, artificial intelligence revolution is they get the most probably either the most senior people or the most skilled person into just coding, and they ask them to apply ML, AI to their topic. You can only do bad things with that. You need to have, we really need to see that this is not just I've applied a neural network and things were better. That's just it. To me, it's if somebody comes along and says, I try to apply statistics and things were better, or I don't know, I read the balance sheet and things were better or not. It's not how you do it. So you need to respect to a certain extent the topic and approach it in a very professional way. So these are the three elements to me that are key to develop something of success and meaningful outcome.
Awesome. Really appreciate that. Thank you for sharing. So one question from the audience was from Samuel Colombo. So Samuel has popped up and clearly knows about Alice and clearly knows about what you're doing, Tommaso. How was the process of designing Alice in order to ensure its explainability?
So to ensure explainability, good question. To ensure explainability, the thing you need to do is to make sure that what you're developing is not a big monolithic thing. Okay, but it's actually a structure thing composed of many different elements. Okay, almost like a waterfall, which is not really a waterfall. It's more like a tree, as you depicted before, right? So you need to do that because by doing so, each component of your algorithm, it's very trackable. You can actually understand what input became the output of something else, who became the input of something else, and so on and so forth. It's almost like a chain. Okay, so if you have something very, very big, it's very tough to understand where it broke. Okay, and how it's working. If you have a chain, it's very easy to understand where the chain broke and what are the weak element and the element that are actually providing more value. So really, to simplify the problem is rather than have a big algorithm doing everything, try to have many small ones doing bits separately. And for sure, you will understand much better how decisions are made. And ultimately, you're able to explain them.
Yeah, that's a great roundup. Really appreciate that. Found a lot of value from that, Samuel. The next question we've got is from Sebastian Piake. Thank you, Sebastian. Since financial markets are typically very non-stationary, what is the average lifetime of ML models used for investments? i.e., do you retrain them on a daily or weekly basis?
So this is another all good question, I have to say. So algorithm in investing, that's all. It's not that they change every day. Okay, it takes a little bit, but you're absolutely right in saying that you need to retrain the models. And the reason why you need to do it, it's because you want to avoid lagging memory. Okay, think about it as a human. A kid can become anything he wants or she wants, right? As we become older, we tend to end up in a position, in a role, doing something. To completely change your career, to completely change your talents, it's almost impossible. Somebody who's a talented swimmer very rarely becomes a talented footballer. It's very tough to do a basketball player. So because all algorithm, to a certain extent, this happens as well, you need to retrain them. How often do we retrain them? Usually we provide a partially fresh neural network every week. And every portfolio everything that we develop is not just one portfolio. So you think that it's one portfolio, but there actually are 15 variations of the same one. So we can monitor how things are evolving to see if there are some weaknesses. Of course, this is how parameters are distributed. The more extreme have more extreme parameters, and that is usually is useful to understand if there are some weaknesses within how your models are working. This is if you're in the investing. If you're doing something which is much closer to the trading, and that's usually where the concept of the model gets older. It's absolutely they get older much faster. That is different because you're not really catching overall market properties. You're catching some arbitrage that they close and open, And so that the pipeline for those algorithms is much shorter. Still, it's not never weeks and a few months. It's always at least 6-8 months, a year or so. The reason is because you have to also to consider that to develop this model, it takes a lot of time. So it's not that this thing completely disappear the day after. If that's the case, maybe the thing you were investigating was not so solid to begin with.
Got it. That's really cool. That's a really great answer. And Sebastian, I hope that answers your question for you, sir. And really appreciate the good answer. We've got 2 more questions. You got time to go through these, Tommaso, quickly?
Yeah, absolutely.
So we've got one coming in from Founder Mikazlizi. I hope I said that relatively correct. And Founder has kindly asked, how do you mitigate bias? What about overfit?
So overfit, which is the concept of learning the data rather than learning the dynamics, is one of the most important things to avoid, if not the most important thing. Otherwise, what you catch is not relevant, just for everyone to understand. How do we avoid that? Well, it's very complicated. So there are different elements. Of course, you can divide your sample, which is easy. You just work on very separate sample. But at the same time, you always have the risk that the researcher, who's the ultimate viewer of the result, can always see the final output together. And he ultimately is producing overfit. So this is why you need to have a structured team also in the R&D. So somebody develops something on a very niche element. It's very, very important to understand why. I told it before. Why is that relevant? Why should it work? So you're not just finding stuff in numbers, but you have an hypothesis. You have a dynamic that you're trying to address. Okay, So that's one thing. And then you have other people who have not developed the first bit of the code to actually test it, to make sure that it works and to provide further testing. So that it's a process. We structure, we have rules to play with. That's a very important thing. And then also you need to have very straightforward rules into not ever have one test that covers everything. Always have limited testing, and when you think it's ready, then you test it. But once you have tested, there's no redoing the stuff. Either it goes, or you have to put the project on pause, because otherwise you might just go back, change a few things, and you think you make it better, but actually it's always the problem of overfitting. So that's the one thing. The biases, how do we avoid them? I mean, again, it's a process. You need to have a very structured approach, but in general, you try to make sure that biases for algorithm, they happens more through data than through how they're developed. So you have to make sure that the data part is rock solid. So I would stress to have people working into how your data silos are created, what type of data you provide in. Make sure that you don't have the same data 50 times just because it's a little bit different. So I make a quick example to give you a better idea. Volatility. 1 week volatility or 2 week volatility, they're basically the same thing. 1 month volatility, 2 month volatility, 2 months volatility contains the 1 month volatility. So you might think it's 2 different things. It's not. And if you have 1, 2, 3 months volatility, you have a component of your element 3 times in. So these are just easy example. Probably the person who posed the question knows very well this, but just to give you an idea, you have to do this for all your data. So for example, we work with macro data, fundamental data, market data. You need to do this for everything. And that's the only way to make sure that you're less exposed to biases.
Yeah, love that. That's a great way of looking at it as well. And a great tip for everyone else watching as well. How to, obviously bias happens, but how to jump over that hurdle. So we've had another question come in since, but I want to ask this one as well. So this one is from Marcelo. So Marcelo has kindly asked, do you use alternative data? And if so, or if you don't, in your opinion, do they make AI more predictive? What do you think?
No, we don't use them. We looked at all very spot on question. We looked at, I would say it's been 6 years, a lot of people doing R&D, the lab. Would be arrogant to say that we tried all the data, but believe me, we tried a lot of data. And alternative data, we looked at them. They're patchy. They are sometimes they complicate the picture rather than simplifying. So it might be useful for a human to create an overview, let's say, but it creates a complex causal effect dynamic. An example of alternative data might be the satellite pictures on Walmart parking lot. Yes, it's cool to tell that you're using satellite picture, but if you think about it, first you need to show me that you have enough picture for all Walmart in all season moments in the market, and that's good enough. Then you need to prove that correlates to less people going, and less people going to less revenues, and less revenues to less earnings. So that it's pretty logic, but still you need to make sure that happens. And even when that's provided, you still need to prove that the market has not taken that information from the quarterly reports that Walmart produces, other ways of getting that information. So the forecast of the analysts themselves. So alternative data might be useful for a human. For a machine autonomously, not that much. In fact, the approach we have is have the best structured data possible. We use a lot of data, believe me, but our goal is not really to cut corners, but it's how do we provide to Alice, our technology, the best cold picture of the market. So we're much more interested into how to project the exact yield curve in the most precise and analytical way, more than some alternative data to cut corners. And I know this is not probably the sexiest answer, but that's just the reality. And we tried. It's not that we didn't believe at the beginning. We tried, but it's just patchy and unreliable.
Yeah, but sometimes that's the best answers, the best practical answers. And then one more question. Have you got time, Tommaso? Sorry to keep coming in.
Yeah, absolutely.
So gentleman here, or Roberta, sorry, ladies, asked, what type of AI do you use, supervised or unsupervised?
A combination of both of them. It depends. It really depends. It's not, as I said before, it's not one monolithic algorithm. It's an algorithm made of different elements, different components. So from time to time, we might use supervised, unsupervised machine learning techniques. You really have to think that because it's a complex problem, getting to a decision in an environment, as one of the member of the audience said before, which is ever changing. You need to look at this not as a huge problem, but as a series of small ones. So each one might be better suited for an unsupervised machine learning algorithm, or for a supervised one. So you have to evaluate and combine them together.
Yeah. And that's always the best way, isn't it? There's not always a one size fits all. I mean, if you look at certain businesses, what works in one business, what works in a food and drink business wouldn't work in an engineering business. So there's always different strategies and tools you need to use. So I think that's a really important point. And that wraps us up. So, Tommaso, we've been chatting for some time, and I feel like I could chat to you forever. I know we've had the call before, and I was really intrigued by what you're doing, and I really do appreciate you coming on. And to everyone that did join, it's completely my mistake for being slightly behind on the timing, but it was really great that we did get to spend this time with you. We've still got more questions coming in, but the team from Tommaso and Alessio can answer those elsewhere and offline, and I'm sure they can help you with all the tools and strategies you need. But Tommaso, I just want to say a massive thank you for joining me today and taking the time to share your expertise, and really excited by what you and the team are doing, and wish you all the best of luck with it. It's very cool to see what you're doing.
Fantastic. Thank you for having me. It's been a pleasure. Look forward to catch up in the future.
Yeah. Another one for sure. Thank you everyone for joining.